In this video, we're going to discuss significant figures. So unlike a math class, in sciences, we divide numbers up into exact numbers and measurements. Exact numbers are values that are counted or defined to have a certain value. Examples of those would be something like 22 students in a classroom. Well, we counted those number of students, so that would be a counted value, and there's no uncertainty. We know exactly there are 22 students. Also, we could say the number of seconds in a minute. That would be a defined value. We know that there are exactly 60 seconds in 1 minute because that is a definition. So with these exact numbers, there are no uncertainty in these numbers. In contrast, measurements are values that have been measured against some standard, where the standard would be your ruler or a balance or a graduated cylinder. So with measurements, of course, if you recall from the measurement video lecture, these have some uncertainty in the number. And that's because the last digit in any measurement is estimated. So these are not exact. So pause the video and see if you can determine which of these would be exact numbers and which would be considered measurements. So 12 inches in a foot, well, that's a definition, so that would be exact. 13 students, of course, that would be a counted value, so that would be exact. 3.45 grams of copper, grams, that would be measured. And 10 meters, that would also be a measurement. I want to stress, though, 10 meters, this is a whole number, and whole numbers do not mean exact. Okay, so if you have a number like 1 or 2 or 3 meters, that is not the same as the exact number. So 10 meters is a distance that is measured, and there's some uncertainty in that measurement. So the reason we talk about measurements and exact numbers is because it leads us into significant figures. Significant figures are defined as the number of meaningful digits in a measured or calculated quantity, including the last estimated digit in the measurement. So significant figures are meaningful numbers in a measured value. So we have to separate those, from, of course, from exact numbers. Significant figures only apply to measurements, not to exact numbers. So we have to think about the difference of those anytime we're performing a calculation. So let's look at a measurement. If you recall, we did something similar to this in the measurement video lecture. Look at this, pause the video real quick, and see if you can determine what the temperature is on this thermometer. Okay, so our thermometer is marked to the ones place, so of course we can estimate to the tenths place. So our temperature here would be 30.0 degrees Celsius. So we know it's exactly 30, and we can estimate the tenths place. So all of these numbers here are significant. So we would say this measurement has 3 significant figures. Let's look at another one. Determine the volume in this graduated pipette. Pause the video real quick and do that. Okay, so here we have 0.3 and 0.4 milliliters. So our measurement, we know exactly it's at least 0.3, but we can estimate one more place, in this case to the hundredths place. So let's say maybe 0.34, 0.35 milliliters. So I said 0.34 milliliters. So we know it's exactly 0.3, or at least 0.3, no uncertainty there. And then we estimate one more decimal place. So these numbers we know with some significance in this measurement. So we would say this number, this measurement, has 2 significant figures. If you looked at this and let's say we said, oh, this measurement is 0.345, excuse my writing here, 3.456 milliliters. Well, again, we can't determine all of these numbers with any certainty, only to the tenths and hundredths place. So the 3 and the 4 are the only significant figures that we have here. They're the only meaningful digits. So if you're taking a measurement, of course, now we know how to determine the number of significant figures, but often when we're solving problems in class or from your textbook, you may be given a measured value that you did not physically measure. and you must determine how many of the digits in that number are significant in order to perform calculations. Let me give you an example of what I mean by that. Let's say you were given this measurement and you were asked how many of these values, how many of the numbers are significant. In other words, how many significant figures does this number have? Well, we have to look at a few rules in order to determine that. So let's analyze this number in a bit more detail. And the question we're trying to answer is how many of these digits are significant and how many are not significant? Well, the first rule is that any non-zero number is significant. So the 4, the 5, and the 7, we know those are part of the measurement, and we know those with some certainty. Okay, so we know there's at least 3 here. Now, the tricky part with significant figures comes with zeros. Anything that's not 0 is considered significant. Sometimes zeros are part of the measurement and therefore significant. Other times, zeros can just be considered placeholders and not significant. So how do we determine which of these zeros are significant and which are not? Again, we have to follow these rules, so be sure you're paying attention writing these rules down. So our first rule, of course, was any non-zero numbers is significant. Our second rule is that zeros in between non-zero digits are significant. These are sometimes called captive zeros. So here we have this 0 is in between the 5 and the 7. It's in between two non-zero numbers. So that 0 we know is part of the measurement and is considered significant. Our third rule dealing with zeros, leading zeros to the left of the first non-zero digit are not significant. These zeros are merely placeholders. So leading zeros to the left of the first non-zero, so here's our first non-zero digit. So we're talking about these zeros, leading zeros over here. These are not considered significant, they're just placeholders. They're not part of the measurement. To illustrate this, let's say this measurement is in grams, but let's convert that into milligrams. If we convert it into milligrams, we move the decimal place 3 spaces, and we would have 4.5070 milligrams. So these zeros here were just holding the place. They're not part of the measurement. So these two numbers here are the same number, just expressed in different units. So again, leading zeros here are just placeholders. So when we convert from grams to milligrams to kilograms, we can add or take away these zeros without changing the actual value of our number. Our fourth rule, zeros at the end of a number and after the decimal are significant. So here we see we have a decimal point clearly given, and we have some zeros at the end of the number and after the decimal. These zeros, sometimes called trailing zeros, are considered significant. Okay, so for this number, we have the 4, the 5, the captive 0 here, the 7, and the zeros at the end are all significant. So to answer our question, how many numbers are significant? How many significant figures do we have in this number? We would have 1, 2, 3, 4, 5, 6. 6 of these digits are significant. These 3 are not significant. They're just placeholders. And there's one other rule that can be a bit confusing. So I put a different number up here to illustrate this. Let's say we had a measurement of 1,700 grams. Here we have zeros at the end of a number, and there's no decimal point. Okay, so these are at the end of the number. There's no decimal point given. These zeros may or may not be significant when the decimal point's not shown. So this number may have 1, 2, 3, or 4 significant figures. They may be placeholders or they may be part of the measurement. Generally, we consider these not significant, but again, you may see different rules, so they may or may not be. So if we want to say that these zeros are significant, we want to put a decimal at the end. So if you see the decimal point like this, we know those zeros are significant. If the decimal point is not there, we generally consider them not significant. Okay, so this number here is written would have 2 sig figs. This number, as written with the decimal point, would have 4, indicating those zeros are significant. So those 5 rules, be sure you're very familiar with those because we use them all through the course. So let's take a look at this problem. Pause the video and see if you can determine how many significant figures are in each of these numbers. Go ahead and pause the video. So for the first number, we have 3 sig figs. Again, our leading zeros are not significant. For this one, all of these numbers, including the zeros, are significant because we have that decimal point. Remember, any zeros at the end after a decimal point are significant. For this number, again, all of them are significant. The captive zeros are significant. Of course, the non-zero numbers are. And these numbers are after the decimal point and at the end of a number. So we'd have 1, 2, 3, 4, 5, 6, 7. Now, $56, that's a tricky one. That's not a measurement. We count money. So that would be counted. That would be exact. So with exact numbers, we could say they have infinite number of sig figs, or essentially we don't consider them to have significant figures. With number 5, 3,000 seconds, again, it may have 1, 2, 3, or 4 sig figs. Generally, we consider it to have only one, but again, you may see different rules for that. These zeros are generally not considered significant. And here, with this number in scientific notation, we still have zeros at the end of a number, and after a decimal, they are considered significant. So we would say 4 sig figs. And one final thing about sig figs, when converting a number into scientific notation, we always write all of the significant figures in scientific notation. So if we wanted to convert this number into scientific notation, we would write it as such. We would leave off the non-significant zeros, but include all of these significant zeros, the captive and the trailing zeros. So when you see a number in scientific notation, all of those numbers we know must be significant. So be sure you're familiar with the rules for significant figures and how to apply them. We use this all the time in chemistry.